Alright, let's look at number 8. So we've got a scatter diagram that shows the relationship between the number of vehicles per 1,000 and the number of people killed in road accidents over an 8-year period. So let x be the number of vehicles per 1,000 and y is the number of people killed. We need to calculate the correlation coefficient. Because they haven't given us the x and the y values here, then I guess we're going to have to put them in ourselves by estimating from the points on the scatter plot. I can assure you that that IB would never do this again. I bet you that there were furious teachers that kids had to spend tons of time during an exam estimating what the x and the y coordinates were for these 8 points. So anyway, let's do our best, and if you want to skip ahead so you don't have to watch this, that's okay. So 245, and then maybe 250, and let's say 253, 260 maybe, 275, 290, 300. Maybe the first one's actually a little lower, so 297 and then 300. Okay, and this now puts in the corresponding y values. The y values I have to put in the same order. So the first one looks to be at about 500 and maybe 10, I don't know. And the second one is about 560. The third one maybe 565. The fourth one a little lower, maybe 550. Fifth one, say 650. No, whoops, now we're on the sixth one, that's about 700. And then it goes up to about 800 and 820. Okay, so once we've got that in, we'll quit and we'll say stat, and we'll calculate linreg, because not only will it give us the line of regression, it will also give us the R value of 0.971 if I'm going to round to 3 significant figures. So R equals 0.971. Explain clearly the statistical relationship between the variables x and y. So this is a case of very strong positive correlation. And that means then that as the number of cars per 1,000 of population increases, as will the number of people killed in road accidents. And that's a fairly reliable correlation due to the strength of the correlation coefficient. Alright, write the equation of the regression line of y on x, and we can see this off of linreg, that y is going to be equal to about 5.20x minus, whoops, x minus 766.8. There we go. Oh, it says I'm supposed to give them correct to 3 significant figures, so perhaps I should change this last one to 767. Now we need to use our equation to answer the following questions. There were 250 vehicles per 1,000. Find the number of people killed. So let's just see if 250 is a reasonable number to choose. Yeah, 250 is inside our data, isn't it? So that's fine. So let's stick 250 into our equation. y equals 5.20 times 250 minus 767. $533 is the number of people that were killed. Explain why it is not a good idea to use the regression line to estimate the number of people killed when the number of vehicles is 150 per thousand. 150 is over here, and we don't have anything in the scatter plot in this area. That would force us to be extrapolating way outside our range of data. So we can only make reliable predictions in between the min and the max, interpolating. If it's asking me about something way out here, lining up with 150, no, that's not reliable. So it would be extrapolating outside the range of x values in the data. And we said that our x values ranged from, let's see, we went from the smallest, 245, up to the biggest, which was 300. So we were going from 245 up to 300. What we estimated. Number 9. We can see the exchange rate between US dollars and euros, as well as US dollars to yen. Enrico has 475 US dollars. How many euros is this worth? So 475 US dollars over, we don't know how many euros, is equal to 1 US dollar over 0.6337 euros. So we would cross multiply. X times 1 is x, and 475 times 0.6337. And yes, of course, you can skip directly to that step if you can see that it's a multiplication by the exchange rate. And we get $301. Or sorry, euros, 301.00. Oh no, it's 0.01, isn't it? If I round to 2 decimal places, and that's what it says, correct to 2 decimal places, well then I need to round 0.01 euros. Enrico goes to a bank to exchange his dollars. The bank charges a 3% commission. How many euros does Enrico actually receive? So the 3% commission is coming off the top of his US dollars. So let's see how much that is. $475 is being acted upon by a 3% commission. And so they remove $14.25 before they even think about converting it. So let's see what actually happened then. His $475 has had this amount removed in commission. So he's actually only changing 460.75. So that 460.75, we see from the previous question that to convert it into euros we need to multiply by 0.6337. So let's see how much he actually gets. He actually only receives 291 euros and 98 cents. Okay. Part B, let's find the exchange rate from euros to yen. Okay. Well, thinking. If 1 US dollar is equal to 0.6337 euros, and 1 US dollar is also equal to 99.7469 yen, then doesn't that mean that these two values must be equal to one another? So 0.6337 euros is equal to 99.7469 yen, since they're both equal to 1 US dollar. And so let's find out then, that's equivalent to 1 European, or 1 euro is equivalent to how many yen, and that will be our exchange rate, 1 to something. And so we'll cross multiply. X times 0.6337 is 0.6337x, and we'll cross multiply the other way, is 99.7469. And that must mean then that x is equal to 99.7469 divided by 0.6337. And we'll work that out. 99.7469 divided by 6337, and it becomes 157, and we want to 2 decimal places, so 157.40. And therefore, our answer is that 1 euro is equivalent to 157.40 yen. Number 10. Astrid invests 1,200 euros. So her present value, 1,200 euros, is being invested for 5 years. Oh, we're compounding monthly, so the 7.2% divided by 12, and let's also do the, because it's monthly, and then times the 100, because it's a percentage, to the power of 12 times, and how many years? For 5 years. So we could just put it into the calculator like this, and we do have to be careful of one thing using parentheses. So 1 plus, so our interest rate 7.2 is dividing the product of 12 and 100. So let's put that product into parentheses, and now close the parentheses that we actually wrote down on the paper, and to the power of 12 times 5. And the $1,200 has grown to 1718.15. And euros, okay. The question actually is asking for the interest that she has earned. So they only want the interest. What I've calculated is the entire future value. So I need to take the difference between the total amount and the principal, and the difference will represent the interest that she has earned over that time. And I'm going to get euros 518.15. Number 11. The value of a car decreases each year. This value can be calculated using the given function. We need to write down the value of the car when it was first bought. When it's first bought, that means that no time has passed. And so we've got then the value is 32,000 times r to the power of 0. And anything to the power of 0 is equal to 1. So 32,000 times 1. So the value of the car when it was first bought was 32,000 US dollars. 1 year later, the value of the car was 27,200. Find the value of R. So after 1 year, the value was 27,200, and we know that V is equal to 32,000 times R to the power of R, and T is 1 here, isn't it? Because 1 year has passed. And so now we can figure out the value of R. We'll divide both sides by 32,000 to get the R alone. In other words, we're kind of we're finding out what the geometric, the common ratio is in a geometric sequence by taking the division of 2 consecutive terms. We're taking one term and dividing it by the term in front, the previous term. So 32,000 is being divided by, you know what? Did I go the wrong way? I did, didn't I? If I'm isolating R, it's 27,200 over 32,000. Let's write this out again. Sorry about that. So let's write it over here. To get R alone, it's 27,200 divided by 32,000. Find the value of R is 0.85. So we had to multiply by 0.85 in order to get the value of the car the following year. That means that the car after 1 year is only worth 85% of what it was before, which must mean that it's losing 15% of its value each year as it depreciates. Now part B, find out how many years it will take for the value of the car to be less than 8,000. So the value is now, let's find out when it reaches 8,000. And so 32,000 times 0.85 is the value of R, and we're raising it to the power of t to find out how many years it takes. And so I know that t might actually be a fractional number. The car is gradually depreciating, and so it might end up reaching 8,000 midway through a year, let's say. So I think I need to use a graph to do this one. My y1 is now 8,000. That's my left-hand side. And my y2 is 32,000 times 0.85 to the power of x. And before I graph this, let's just consider my window. I need to make sure that 8,000 fits in for my y-max. So I'm going to put it safely above it at 9,000. And it's possible that it takes many years to occur. It could, well, actually, I think it's probably going to take 10 years to depreciate to that amount, but maybe I'll just be safe and assume maybe it's going to take as long as 15 years. Let's now graph it. That's the 8,000. We want to find out when has 32,000 car diminished, and that's right here where it finally hit 8,000. So let's find the intersection. Second calc intersect, enter, 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 and we discover that they intersect after 8.53 years. So t is 8.53 years. And to show my work, I should just show a quick sketch of the graph. That's y1 is 8,000, and then I've got this falling function with an intersection at 8.53, 8,000. And the function of the other one is 32,000. So that's my y2, is 32,000 times 0.85 to the power of x. So let's just label the two functions and then show the intersection point in the graph to show our work. And the last question is number 12. 8 students in the PE class did push-ups and sit-ups. There are the results, and we can see that all of those results have been graphed onto a scatter plot. We need to plot the results for the 8th student on the graph. So I'm just verifying. So 2432, that's this one right here. So that's our student 1. And then 1828 is this kid. And then 3238, that's right here. 5140 is right there. 3530 is right there. Kid 6 was 4252. Wait. Has that one been graphed? 4252. Maybe that's what this one's supposed to be. It seems a little off, but oh well. 7, 45, 48. They all kind of seem off, but oh well. And then number 8, 25, 52. 25, ooh, we don't have that kid. That's what they mean by the 8th one then. So 25, 52 appears to be right about there. There's my 8th kid. Part B. It gives us the 34 and 40 as the means of the x and the y. And so let's draw the mean point on the graph. 34 and 40 is right here. So I'm going to label that M with coordinates 34 and 40. And my line of best fit has got to go through that mean point. So Well, it's a little bit of an estimation here. I kind of want approximately an even number of points above and below. So I'm thinking that if it's got to go through there, maybe something like that. Maybe it's a little steeper. Yeah, something like that maybe. It's a bit of guesswork here, but I think that's fair enough. As long as it goes through the mean point, and as long as you draw a ruler to draw a straight line, and that you do show what the y-intercept is. Please do extend it all the way to the y-axis. Okay, a student can do 60 push-ups. How many sit-ups can a student be expected to do? This is really kind of a tricky question because although I could sketch up from 60 and then across to the sit-ups to be able to estimate that a kid who does 60 push-ups is going to do around 55 sit-ups, I'm a little nervous about this because that 60 is actually outside the range of data that I've been given. This is an example of extrapolation. Now, how bad is the extrapolation? I mean, my maximum number of push-ups, the maximum x value in the given data was 52. So 60 isn't that far outside, but I'm kind of uncomfortable with this. So I'm just looking at the wording of the question. They really do seem to be expecting an answer, don't they? So, boy, I guess we just say 55 sit-ups. But I'd be tempted to say it's, maybe I'd say 55 sit-ups, although we can't be sure because it's extrapolating beyond the data set. That might be a nicer answer because then you kind of cover both bases and demonstrate the examiner that you really do know what you're talking about. Anyway, that concludes the review for this test on two-variable statistics and financial mathematics. Good luck studying for this final test of your grade 11 year.